Okay, well, I'm going to get started because if you're on your lunch break or you're taking some time out of the workday, I want to make sure that we value your time and get right to it. So thank you again, everybody, for joining. And as you can see from that first slide, today's topic is the combination of heat pump technology and weatherization. So the bulk of today's presentation is actually going to be on heat pumps, and I'll introduce you to my co-hosts who will also be presenting today, who will talk about some of their incentive programs and offers when it comes to heat pumps. So only one slide today on weatherization, but we want to talk about what the benefit is of both of those things coming together. And look, I got a little curtain action. I had fun with the animation this week. So you're seeing the unveiling of an example of some of the prizes that we have. We have a prize basket giveaway that we're doing each week. So if you're attending, hats off, you have been entered into our randomly drawn prize basket winning. You could get in that basket some of the delicious goods from King Arthur Flour. Maybe it's a scone mix. You could get a bunch of darn tough socks, or included in there might be some Lake Champlain chocolate. So thank you for joining. And if you know someone who wants to be entered in to win one of these great gift baskets, invite them to the next Weatherization Wednesday or get them to join in the next hour. So exciting stuff. Okay, so this is our agenda for today, and I'm going to start by introducing our co-hosts. So first up, we have Lisa Morris from the Vermont Electric Co-op. She'll be joining us and presenting on their offers in particular. Thank you, Lisa. She's one of the energy services planners for VEC. Next up, we've got Brian Riley from Burlington Electric Department, BED. He'll be also sharing their incentives and offers. And oh, there's Brian. Thanks, Brian. After Brian, we've got Julia Leopold, who's a communications specialist with VPSA, which stands for the Vermont Public Power Supply Authority. Got that acronym. And Julia will talk a little bit at the end as well. She's got some slides on the cost analysis as it relates to heat pumps, so look out for that. We've also got Washington Electric Co-op's Bill Powell. If you're a Washington Electric Co-op member, you probably know Bill. So I'll just say that. Green Mountain Power, we've got Dan Mackey, whose title is Innovation Champion. So certainly the right guy to call if you've got some innovative ideas. And then last but certainly not least, we've got a twofer with us. We've got folks from Stowe Electric. We've got Michael Lazarchak and Trish Waugh. If I got it wrong, Trish, you correct. Yay! Trish will correct me later if I got it wrong, but I got a thumbs up there, folks. Okay. So those are our co-hosts, and I'm going to have them present on the different utility offers that they have. And I'll tell you a little bit why we wanted to invite your utility partners today, because there's some interesting incentives when it comes to heat pumps. So we work really closely at Efficiency Vermont with all of the different utilities. They're great partners, and they offer incentives on heat pumps as well. And a few of them actually have a combo deal when it comes to weatherization and heat pumps together. So just to give you a primer on weatherization, the whole purpose of the Button Up Vermont campaign, weatherizing your home. If you were attending last week, you know this slide. It's still my favorite. The analogy I like to use for weatherization is when we think about our cable knit sweaters, our nice, warm, cozy sweaters. Maybe you're nice and cozy with your cup of tea. And that is your insulation. But you wouldn't just wear a nice cozy sweater outside. Most Vermonters know that wind or air might travel through the knit of that sweater. So what you want to do is pop on a windbreaker, which represents our air sealing, to get the combined benefits of the two of those things. So for today's presentation, I like to picture weatherization as that starting point when it comes to making a consideration for getting a heat pump. You want to have a tight, air-sealed, insulated home so that you're ultimately needing less energy, less hot, less cold energy to keep you comfortable in your home. It's like the starting point before you think about maybe a next project. But today we're going to talk about once you've weatherized or you've completed those projects and you're thinking about a heat pump, here's what you want to know. So there's 3 ways you can weatherize. There's income eligible weatherization, which is free for Vermonters statewide. There's the comprehensive weatherization through Home Performance with Energy Star. And then there's also do-it-yourself projects. So ideally, you'll have completed a large project like a Home Performance with Energy Star. And then the cherry on top is that heat pump. So let's dive right into the heat pump conversation. I'm going to do a quick overview about how heat pumps work. And I'll just put it out there. It is just a little bit of science, but also to me, it feels a little bit like magic. So we start out with 2 units when it comes to a heat pump. You've got an indoor unit and an outdoor unit. The indoor unit is a unit that's placed within the heat source. An outdoor unit is where you have the heat source. So it's where you're pulling in heat. And a unit that's placed within the heat sink, that image on our right, that's whatever you're trying to heat. So that's why we typically see an outdoor and an indoor unit. You're thinking about your heat source and you're thinking about your heat sink. So the evaporator, which let's see, can I? Boom. The evaporator pulls heat molecules in and the air actually runs through a refrigerant and the cold molecules are released and they're pushed through a compressor. See if I can time it. Oh, do you see my compressor? There's my compressor, which increases the temperature and the pressure within the refrigerant. So that indoor unit then releases the heat and sends it through the refrigerant and outside to repeat the process. So we're seeing that. Boom. So that's essentially the reverse of what you might have on the back of your refrigerator. So if you're familiar, like you touch the back of your fridge, it's very hot. It's because it's actually cooling the inside of your fridge by pulling out the hot air rather than changing it from hot to cold, which is what you would see in something like resistance heating, like resistance electric heating. So the same example might be with an air conditioner. This is one of the cool things about the heat pump. One of the essential things, if you're thinking about making the switch, it's the energy savings. So for every 1 kilowatt hour on average of energy, you actually get the equivalent of 3 kilowatt hours of heat output. So that does depend on outside temperatures, but very cool. That's the kind of thing you want to see with a high efficiency project or product, because you want to see lower energy being needed to produce higher heat output. So that 1 kilowatt hour to the 3 kilowatt hours worth of heat output. So there you go. That's my most technical slide. And I should note, if you have questions throughout this, if that was like a bunch of information and you have questions, please go ahead and put it in the chat or put it in the Q&A because we are going to take questions on the topics today. And we'll spend the bulk of the end of the presentation answering them. So feel free to put them in now. And while I may not answer them during the presentation, we will get to them at the end. So now that you understand a bit of the science of a heat pump, I want to talk to you about the most common options. So ductless heat pumps are, for the most part, the most common option here in Vermont. In this case, that heat sink would actually be a room in your home, and then that heat source is that outside unit, which over here. And then that outside unit actually is, so what we call, it's like the ductless heat pump because there's no ducting. So you actually are just there on the outside unit, you have it on the wall, and then the inside is typically right next to it. So rather than having a lot of ducting, which you might see in some older forms of heating and cooling. It's all right there. So you don't need a lot. It's very plug and play. And that's why I think a lot of Vermonters are adopting it. So they work even on the coldest Vermont days up to negative or down to negative 20 degrees is what they're rated for. While their efficiency does decrease somewhat on colder days, we still, because of that, we still recommend having a backup source of heat, but still great technology even in the winter. You know, I've got some snowflakes on this slide to help reiterate that point. And then I also want to note that when we say heat pumps, it's not just heat, it's also cooling. And many Vermonters that I run into say when they get their heat pump that they love it for heating, but the real benefit is cooling. If you've got air conditioners in your windows, or you are just feeling uncomfortable in your home during the summer because of our extreme temperatures, really a great choice is to think about a heat pump because of that cooling, because it does the reverse. And actually the efficiency can be even higher in the summer. So I wanted to show you a couple pictures of, now that you've seen the graphic, what does it actually look like when it's on your home or outside your home. Here are some examples of outdoor units on different homes. And you can work with a contractor, for example, to install a roof to protect it from snow if that's an issue. So you see our lovely snow cover right here with this heat pump. I also want to show you some indoor examples. So the most common type is actually the wall mounted. So you'll see that here and here. But there are also ground source or ground mounted units that look a lot like space heaters. So whatever you decide to install, you're going to want to have a conversation about that. And depending on your home size and layout and how much heat you're trying to offset, you may decide to install more than one unit. But even if you just have one unit installed in a central place, like an open living room, open kitchen, you can actually offset your fuel use significantly. So even with one, you can have a big impact. And for many Vermonters, the conversation that they're trying to have is, where's the ideal location? Because you might have an older home with lots of little rooms, but one space that's big and open. We tend to recommend doing that open space area so you get better bang for your buck. So next up, I'm going to talk a bit more about the heating and cooling aspect and give you some examples of some other types of heat pumps. The first I want to mention is ducted heat pumps. So we've talked about the ductless, but if you'd rather explore a whole home solution rather than the point source option, which is that ductless, you can also find some rebates and some incentives and pursue that type of project. So rather than being like a point source or space heater like, the whole home heat pump actually gives you the option to distribute the heating throughout your home. And it actually could, and this is, I hear a lot of questions about this, so you might ask this, can it be retrofitted to fit into an older existing ducted system? It depends. Definitely people have looked into that. The centrally ducted systems still work just as well in cold climates, so no concerns there. But rather than heating a room, the hot air actually flows through that ducted distribution system and vents throughout your home. So that option would be also able to provide some air conditioning if you want that ducted setup as well. Then second, I've got some air to water heat pump information here. So that would use the outside air to heat water, and the hot water then flows through radiators or radiators, depending on what part of Vermont you live, or radiant flooring. And the hot water, you know, in that scenario would actually potentially use the same system to heat your household hot water that you might use for showers or cleaning. And it's important, I want to take a pause here because it's important to know that these systems don't work in all homes. Air to water systems are typically designed to be put into a home from the start. So if you're excited by this air to water heat pump system, I do just want to put the caveat out there that unless you're building new, this is a difficult retrofit. But people definitely, it would be difficult, but I have seen it. I have seen people have those conversations. So we can certainly answer more on that one. And last but certainly not least, I want to talk about ground source heat pumps. So those actually pull heat. They pull stored heat from the ground or groundwater, and then it circulates through your home. And ground source heat pumps have the highest efficiency of all heat pump systems if they're properly installed and all that good stuff. However, things like the excavation costs for doing a ground source heat pump system, it actually also makes them the most expensive option. While there are some new technologies that are decreasing that cost overall, we are, it's coming, I would say more so for the average person. And we at Efficiency Vermont have some rebates when it comes to ground source heat pumps that are hoping to dig deeper on that topic too. So, but like the ductless heat pumps, they work equally well in the summer. And they can be connected to a hot water system. Okay, so I've got just two more topics to cover for you. And for many of our utilities here today, they also have incentives for not just the heat pump classic heating and cooling, but also heat pump hot water heaters. So heating your water with a heat pump is actually super efficient. So thinking back to that lovely science part that I had at the beginning, the technology is the same here as it would be for those heating and cooling systems. The big difference, though, is that there's just one unit rather than having the outdoor unit. So for me, I have a heat pump hot water system, and the benefit there is that for me, it does pull from the surrounding area in our basement. It pulls, it's a heat source and heat sink right there. The benefit is it's also dehumidifying when it does that. So if you're in if you have a musty basement or you've got some moisture, a heat pump hot water system could also dehumidify, which is a big benefit. It depends on where you're installing it though. That's something you want to consider, because if you're not going to get the benefit of the dehumidification, you might want to place it you're going to want to have a conversation about where to place it. If you're comparing getting a heat pump hot water system to your existing like hot water heater, what we found is that heat pump hot water heaters use 1/3 to 1/2 of the amount of electricity that the standard electric hot water heater uses. So a very significant savings there when it comes to energy, just about a decrease of 50 to 66% in water heating costs. Now, while I could go on and on about how much I love my heat pump hot water heater, I do want to note that if you are thinking about a heat pump hot water heater, definitely look into the incentives, because those are also going to help you. Okay, so as we start to wrap up this part of the presentation, I've sprinkled throughout some of the benefits of having a heat pump hot water heater or a regular heat pump, but I want to just be more specific about those so you can start to make a decision for yourself. So how could a heat pump help you? The first is it could help you save energy and reduce carbon pollution. I'll talk a bit more about that. It could also save you money and cost on your bills, whether that be your fuel bill or your potentially lowering if you're switching from an already electric source of heating. And then last, but certainly not least, it can also help you be more comfortable. So this is the part where I get to pass the torch for a moment to Julia Leopold, who is from VIPSA, and she's going to give us some information about that saving money part when it comes to heat pumps with some cost analysis. So I'll still drive, Julia, but you tell me when to switch.
Sure, you can go for it. So hi again, everyone. And Becca, thank you for having me here today. I really appreciate being part of this Button-Up Weatherization Wednesday webinar. A lot of folks, when they're considering purchasing a heat pump, the first thing that they ask is if this is actually going to save me money. And like most things in life, the answer is it depends. So what I want to do is just walk you through a few different things that you can consider if this is a type of technology that you're interested in. So the first thing, and Becca already mentioned this, is how do you plan to use your heat pump? Are you going to use it for heating, for cooling, or for both? And the good news is that there are opportunities to save if you're using it for either heating or for cooling. The second thing to consider is how much does it cost to install the heat pump? And then finally, how much does it cost to run the heat pump? So again, we mentioned heating versus cooling. There are opportunities to save on both sides, but let's dive into some of the costs regarding installation. So how much does it actually cost to install a heat pump? And again, the answer is it depends. So you have to think about your home. Like Becca mentioned, that heat pumps are really great for heating or cooling a large open space. In Vermont, there are a lot of homes that don't necessarily have that. You might have an older farmhouse, which is partitioned off into several different rooms. That might mean that you could consider a type of heat pump where you have one outdoor unit attached to multiple indoor units, and that's going to change the price of the heat pump. Weatherization also plays a really huge role. If you are heating a home that's leaky, you get that chimney effect. The heat rises, maybe it leaks out in some of the crevices in the attic. No matter what, whether you're heating with a heat pump or with fossil fuel, you are going to be spending more money on your heating because you're losing it to the outside, which is why the weatherization component is so important when it comes to heat pumps. They operate much more efficiently in a tight home. Again, I mentioned the layout of your home, open floor plan versus many closed off rooms, and also just how big your home is. If you're talking about maybe a raised ranch that's got about 1,800 square feet, that's going to be a lot less to heat than this big sprawling estate of 3,500 square feet. So again, you have to take your home into consideration in order to determine how much you're going to be spending on that initial installation of the heat pump. I will say that as someone who has processed several rebates for heat pumps over the past couple of years, I would say that the average single zone heat pump installation is going to cost you probably around $4,000 to $5,000. Next slide, please. Oh, and there's a pretty big range though. That range is around 2,500 to 12,000. I've definitely seen heat pumps costing all across that range, but the average is around 4,000 to 5,000. All right. So now this is where it gets a little trickier. How much does it cost to run a heat pump? And to look at that, as you all know now, heat pump runs off of electricity. So you are going to be spending money on your electric bill in order to run your heat pump. The question is it more or less expensive than your alternative options? So what I've done here is laid out the current prices for propane, natural gas, heating oil, and electricity. These numbers were pulled from the Department of Public Service. They have a monthly report on costs of fuel sources. That's where I got the numbers for propane and for heating oil. For natural gas, I pulled numbers from the VGS website, with VGS being Vermont's natural gas supplier. And electricity, that cost of 17 cents per kilowatt hour is the average cost. Depending on your electric utility, might be a little bit higher, might be a little bit lower. I know for VEPSA, we have 11 member electric utilities, and I believe the lowest cost among our membership is 11 cents per kilowatt hour. So you want to take that into consideration. If you have a lower electric rate, it might actually be more beneficial to have a heat pump compared to maybe some other higher electric rate utilities. So the thing about these units is that they're all over the place. They're hard to compare to each other. So what I've done is converted from, cost per gallon, cost per therm, over to a cost per MMBTU. And what that does is just gives you an apple to apples comparison. So you can see that with that slide or with that graphic on the right, propane now becomes the most expensive option for heating your home, where your heat pump becomes the least expensive option at $24.91 per MMBTU. Or I'm sorry, I should actually say natural gas is the least expensive. The only issue that I would say is that there's very limited access to natural gas in Vermont. So most of us are heating with propane or with oil. A lot of us are also heating with wood. I didn't include that on here, but it's certainly something we could discuss more. But on the next slide, what I want to show you here is just the cost to run the heat pump at different temperatures. And the reason why this is important is because Becca mentioned it earlier, heat pumps change their efficiency depending on the outdoor temperature. So if you look at the 47 degrees scenario, it's 47 degrees outside, you're running propane at that $41 per MMBTU, but you look down at electricity and it's around $12.46 per MMBTU. So electricity with the heat pump is the clear winner when it's pretty mild outside. I would say a lot of us probably think 47 degrees. It's not frigid cold, but if it's going to be 47 for a stretch of several days, you probably want to have some source of heating inside of your home.
Let's take shoulder season.
We'll take you into the 17 degree scenario. And I want to just point out real quick, if you look at propane, natural gas, heating oil, those costs per MMBTU don't change regardless of what the outdoor temperature is. It's always going to be the same. And that's because your fossil fuel heating system is pretty much always running at the same efficiency, where again, a heat pump, the efficiency depends on the outdoor temperature. So in this scenario, you can see that the needle is moving a little bit in favor of natural gas. But if you look at the heat pump, it's still a pretty competitive option. It's still under $25 per MMBTU at 17 degrees. And I have to say, in Vermont, we get very cold. We all know that. But we don't see those intense, super cold temperatures for really long periods of time. So I think 17 degrees is a pretty reasonable temperature to say that we're at during the winter. Once we start getting down to around 5 degrees, and you can pull that up now, Becca, if you'd like. That 5 degree scenario, you can see it is becoming a little more cost effective to run heating oil at today's prices. Of course, the price of oil could change. That would throw this whole equation off. It's just something to keep in mind. But at 5 degrees, it's still not a bad option to run your heat pump, but I would say most will probably switch to their fossil fuel backup at this point. Not to say you can't entirely heat off of your heat pump, it just might not be the most economical thing to do. So on the next slide, we're going to say, will I actually save money? And again, it depends on all of the things we just talked about. But I want to just point out that back in 2017, the Vermont Department of Public Service did conduct a study on heat pumps. They had been studying those heat pumps for 2 years. They released the report in 2017. It included studying 77 heat pumps installed at 65 residential locations throughout Vermont. There was a wide variety of energy savings reported, but overall, there was an average energy savings of $200 per heat pump per year, which is pretty great. It's nice to know you can actually save money. But I just want to put that into perspective that if you are installing your heat pump for $4,000, that's a 20-year payback period. So it does depend, how long is my heat pump going to last? Will it last those 20 years? Will I get my payback? And then if you're using your heat pump for cooling, it could change that. The thing about using your heat pump for cooling is that if you've never had an air conditioner in your house ever, you are going to spend more money on electricity. But if you have like 3 or 4 of these clunky old window units running, then you're probably going to save money because you've been running something that's really inefficient and replacing it with something much more efficient. And I think that that's why in this last bullet point, no surveyed homeowner expressed dissatisfaction with their choice to install a heat pump. What that tells me is that even if you maybe aren't getting incredible financial savings on your heat pump, you're probably going to experience benefits in other areas. And that could be maybe using less fossil fuel. It could be being more comfortable. A lot of folks in Vermont, especially in these recent years, going through these very hot summers, we want more cooling and we want to cool more efficiently. So it's just all these things to think about. Again, can't say for sure that you will save money. It depends on your situation. But something I can say is that these are all numbers that you can work out either on your own or with your contractor should you decide to investigate installing a heat pump. And that way you can go into that decision a bit more informed. So hope that helps you out a little bit.
Awesome. Well, thank you, Julia.
Sure.
That was very informative, and I love that you got the ability. You showed us all the different ways to compare that, but gave us that MMBTU. That's huge. And let's say you've just heard what Julia had to share. She'll be back again to tell us about what VPSA has for incentives. But let's say you've just listened to all that and you're thinking, why was no one who was surveyed? Why did none of them express dissatisfaction with their heat pump? Well, that's a great segue to some of the other benefits to heat pumps besides the potential to save money. The other benefits include feeling more comfortable. I mean, look at that smile. That's a person who has dehumidification, who's got air purification, who's got a whole home or whole room solution. And she just set that heat pump and forgot about it. She's able to have her iced tea and watermelon and not worry about the heat or the hot or cold in that room. I want to underscore the air purification piece as well, because if you've got pets or like dander, one of the benefits of a heat pump is they do have a filter. That's what we mean when we say air purification. So I've heard from many pet owners the benefit of a heat pump. And last but certainly not least, saving energy and reducing carbon emissions. So you could reduce your fossil fuel use, as we saw with that comparison from Julia. If you're reducing your overall fossil fuel, you're also helping contribute to Vermont reaching our statewide energy goals. You also, and our utilities are a great example of this, you also are likely to be you're having a much better mix with your electricity when it comes to renewable energy. So even if you don't have solar at your home, there's a good chance that the mix when it comes to your utility is very positive for renewable energy. So when you're heating and cooling your home, you can either get solar or get a renewable energy technology to combine those benefits for, heating or cooling with the sun, or there's a good chance that with your electricity company, you are actually seeing a very good mix of renewable there otherwise. So this is the part where I get to introduce our co-hosts, and I see we have a ton of questions and a ton of notes in the chat. So I'm going to have each one of these folks introduce themselves and talk a little bit about their programs, and then we're going to quickly get to all of your questions. So thank you for your patience. We're going to definitely leave some time to answer all of those. Okay, oh, and I forgot one other slide. I did want to mention the home energy loan. Up to $20,000 you can finance to include a weatherization project, heat pumps, or other heating like wood heating systems, for example. Did want to mention that, and to note an error on the last Weatherization Wednesday, we had a slide that said up to $40,000. The home energy loan is up to $20,000. So wanted to clarify that. Okay. Julia, you're back on deck. Thank you so much for giving us those great slides. Tell us a little bit about what VPSA has to offer when it comes to this conversation.
Sure. And just a really quick overview for anyone who might be listening who maybe has never heard of Vermont Public Power Supply Authority. We're an organization that provides services to municipal electric utilities around the state. There are 17 electric utilities in Vermont. 14 of those utilities are basically run by the local government within the municipality. And of those 14, 11 are members of Vermont Public Power Supply Authority. So we've kind of joined forces and said that Vermont Public Power Supply Authority, or VPSA as we call ourselves, will be the ones to offer these incentives on behalf of our member utilities. So over underneath our logo, you can see that is our list of electric utilities. If you are watching and one of these utilities is yours, then I am your girl. I will talk to you about your incentives. So on the right, you have the bullet points that list all of the different offerings that we have for heat pumps. So there's first up the $250 instant discount for a ductless heat pump installation. That is, again, offered as a point of sale incentive. So what you do here is you work with your contractor, they install your heat pump, and they will pass through a $250 instant discount. In a lot of cases, this is combined with an incentive that's offered by Efficiency Vermont. And this is also offered across, I believe, every other electric utility. So this is not unique to VEPSA. Pretty much everyone in the state has access to this incentive. What VEPSA does that is a little bit different is that we offer an additional $200 for installing a heat pump in a building that has completed a qualifying weatherization project. The two common ones that we see are home performance with Energy Star, which Becca mentioned earlier, and you can learn more about that project by visiting the Efficiency Vermont website or by working with a member of the Energy Efficiency Network of Contractors through Efficiency Vermont. The other one that we see is a weatherization project through the Weatherization Assistance Programs, which is available to income qualifying Vermonters. So again, you complete the weatherization project, you install your heat pump, you fill out a form that's on our website, vppsa.com, you mail it to me, I send you back $200. We also offer a $600 instant discount for heat pump water heaters. This is kind of an interesting program with Efficiency Vermont that we're participating in. Essentially, Efficiency Vermont offers an incentive for anyone who installs a heat pump water heater to replace an electric resistance water heater. But if you are replacing a fossil fuel fired water heater, that instant discount still happens, still comes from Efficiency Vermont. It's just we're giving them the money to give to you. And again, that's because part of our mission is to help decrease fossil fuel use and the greenhouse gases associated with fossil fuel. I'm going to try to wrap this up quick because we have a lot of others to get to. We do also have this fantastic offer that's occurring right now. It is a very limited offer. It is only for income eligible homes. It's $2,000 for installing a heat pump and completing a weatherization project. And this is only available to customers of Barton Village Electric and Jacksonville Electric Company. The idea here is that we want to just make it that much easier for income qualifying homes to both button up their home and also get that efficient source of heating. We also offer a lot more when it comes to rebates. What I recommend doing is visiting vppsa.com. You're also welcome to reach out directly to me, and you can find my phone number and my email address on that website. Thanks, Becca.
Thank you, Julia. And yes, I see we've got a bunch of questions, so I'm going to jump right to it. Next up is we've got our friend Bill Powell from Washington Electric Co-op. So Bill, tell us a little bit about your Button Up 2021 incentives and how this all relates to heat pumps too.
Thank you, Becca, and thank you for EBT for putting this on today. The Washington Electric Co-op serves 41 towns in central Vermont. Our incentives, similar to what you've heard already from Efficiency Vermont and from VEPSA, are in part provided in conjunction with those incentives from Efficiency Vermont. And I'll leave the slide up as it is. I think it's self-explanatory. What I'd encourage you in the audience, if you're a WEC member, and you got questions, please reach out to me at the co-op, Bill Powell, and I'll be glad to help you kind of finesse your particular situation. I'm pretty familiar with all the technologies, and I think one of the useful services that we provide is, and I think both Becca and Julia have made this point, the cost effectiveness of any such equipment upgrade, even if your utility like WEC is 100% renewable, it depends. There's both an operating cost and a capital cost that's your own pocketbook, whether you're getting incentives or not. And if you want to make that kind of decision on a return on investment basis, I can help. Many members make these decisions without a whole lot of consideration, and there are potential downsides to switching from in particular buildings. If the heat load is high and you haven't weatherized, as you've heard already, that's probably not a good place to put in a heat pump. But again, what I'd offer is, if you have questions, if you're a WEC member, please contact me and I'll be glad to help you. Thank you.
Thank you, Bill. And thank you for the offer. I bet we have some WEC folks tuning in. So if you want to shout out your utility, feel free to put it in the chat. I've been collecting our questions as we're going. So hopefully we'll be able to get to everybody, but let us know who's your utility in the chat. Next up, we've got Dan Mackey, our innovation champion from Green Mountain Power. Same question, Dan. What's going on?
Oh, everything. All kinds of rebates and lots of offers out there, whether it be for heating and cooling your home and other things such as electric vehicles. But primarily, we have some really good rebates for cold climate heat pumps and heat pump hot water heaters, very similar to other utilities. We also have a very good offering for geothermal systems, which are the ground source that you had mentioned earlier, which I would strongly suggest that if anyone has any questions, feel free to reach out to me or anyone on the Green Mountain Power team, in which gladly answer your questions. And to Bill's point, one of the things you want to make certain is you do have a decent thermal envelope when you actually do install a heat pump, because you're going to see some huge benefits in which folks who install them absolutely love them. But understanding how to operate the unit is very, very important. And one of the features I want to mention out there that's on all heat pumps I've seen is the auto feature. And the auto feature is designed for heating and cooling your home in a location that has much closer temperature ranges than Vermont, in which the auto feature, you could put, we had a customer who actually put a heat pump in a sunroom, and all night the heat pump would heat the place and keep it very, very comfortable when they had the drapes pulled. During the day, when they opened up the shades or the drapes, the unit would switch to air conditioning. So, and that could be happening on a 20-degree day in January, in which that's not the most efficient use for a heat pump. So avoid the auto mode and reach out. As I say, we have lots of offerings and really appreciate the opportunity today. And when we get to the question and answers, if you'd like me to answer some of those, Becca, by all means.
Thank you, Dan. Yeah, and great tip. Good tip. Next up, we've got Lisa from the Vermont Electric Co-op. Let's see. There we go. Hi, Lisa.
Hi, I don't know if everybody can see me, but thanks for having me. I'll keep this short because I know we're running short on time here. But yes, I work at Vermont Electric Co-op. We're a not-for-profit member-owned cooperative, and we serve the northern 1/3 of the state of Vermont. So similar to what you've heard from the other utilities, we're partnering with Efficiency Vermont for a lot of these incentives. So for the Ductless, Ducted, air to water, and ground source heat pumps, that's an incentive that goes through the Efficiency Vermont program, and then we're supporting that to keep it as streamlined as possible for our members. But on top of those incentives that are offered through the Efficiency Vermont programs, if the building that the heat pump is being installed in meets thermal efficiency criteria, similar to what Julia was talking about with VIPSA, we're offering an additional $150 incentive per unit for those heat pumps, which would be a bill credit. So there's a simple form that you would submit to VEC, and then we would put that on your bill. And then the same process for heat pump water heaters. So we offer a $250 bill credit for those, and a $150 bill credit for pellet stoves as well. And this is all through our energy transformation program, which you can find more information about on our website. And the mission of that is to help our members transition away from fossil fuels. So thanks for having me, and feel free to reach out to VEC with any questions you have about our incentives.
Thank you, Lisa. This is great to have everybody here. If you are recognizing familiar faces from your utility, you're in the right place. Next up, we've got our friends at Burlington Electric Department. We have Brian Riley. Brian, take it away.
Hey, good afternoon. Thanks for having us on. Hello to some of the panelists whose names and faces I recognize, and thanks to all the folks who joined. So yeah, just a little bit about Burlington. So we have about 8% of the total kilowatt hour sales in the state, and about and if we look at the total area that we serve, it's maybe 15.5 square miles. So, the energy that's used per square foot or per mile, right, it's really high. So some unique conditions in Burlington. So Burlington Electric Department is a distribution utility as well as an energy efficiency utility. So we are the energy efficiency utility for Burlington. Burlington has a goal to become a net zero energy city by 2030. So that's, excuse me, currently all the electricity is sourced from renewables, and we are targeting ground transportation, so e-bikes and electric vehicles and public transport, and also a big emphasis on the thermal sector. 95% of Burlington is heated with natural gas. I should say the residential market is, and 85% of the residential market heats their hot water with natural gas. So, I mean, Burlington Electric Department doesn't really have much a game in the weatherization world. So we try to align our weatherization programs as closely as possible with those from Vermont Gas Systems, and you know, we try to support folks as much as possible that are going to be installing heat pumps in gas heated homes. So this is like the hybrid heated homes, and we will pay, you know, for a portion of the audit and the weatherization, and you know, we'll handle all that sort of behind the scenes with VGS. So we encourage folks to sequence the heat pump install or the weatherization work in whatever manner that works best for them, and know that they're not going to miss out on the opportunities. So what else? So all of our rebates are sort of fall into this green stimulus program, which is our code response. And so they're quite generous in many regards. I'm not going to, you know, run through the numbers because they're really dizzying, but I do encourage folks to look at our website, and also just email us at efficiency@burlingtonelectric.com for specific questions or just general conversations. I'm glad, Becca, you mentioned the cooling piece as well, and there was a recent VT Digger article. Title is "New Study Reveals Burlington is Trapping Heat on Par with Much Larger Cities." And a study published Wednesday revealed that Burlington is on average 7 degrees warmer due to its design and layout than rural areas in Vermont, otherwise experiencing the same climate conditions. I mean, that's really interesting to me. I mean, we get, although I don't get a ton of calls about for folks that are heating related, I do get a ton of calls regarding cooling. And so that is going to be an ever growing market sector. So even more important to weatherize and more important to have efficient cooling. What else can I say? We have, you know, the rebates for the space conditioning equipment. So those are the ductless systems, and then the centrally ducted systems, as well as air to water and ground source. And I think if, again, if folks have specific questions on this technology, rebate amounts, the process, how to apply, you know, please just email us, or feel free to call, email, or check our website.
Thanks, Brian.
Thank you.
Thank you. And I see we're getting a lot of questions. So I know that we end these at 1, and I'm going to really try to get through some questions. Next up, we got Michael and Trish from Stowe Electric, and then we'll jump right to your questions. Thank you for your patience, folks. Hey.
Okay. Yeah, I'll make this quick. Becca, I'm Michael Lazorchak. This is Trish. I administer the Tier 3 program for the Town of Stowe Electric Department. If you're in our service territory, you can call or email me at any time. And to Becca's earlier point, we do provide a post-purchase rebate for the ductless systems, knowing that they are popular, especially among our residential customers. And with that, I'll turn it back to Becca for questions. Thank you.
Awesome. Thank you. So I'm going to stop sharing, folks. And at this point, there we go. Stop share. We should all be able to see each other. So all of our panelists are welcome to come on camera if you'd like to. But let's dive into these questions. Okay, so the first one is, what kind of maintenance do heat pumps require? Is there any annual maintenance? Anyone want to take that?
Sure, I will.
Go ahead, Dan.
Dan from Green Mountain Power. So one of the things they recommend is you actually clean the condenser at least annually. That's the outside unit, and make certain that leaves and debris are completely away from it. The unit will get plugged up with dust, but it's not very expensive to have it serviced, very similar to your furnace. The evaporator head or the inside unit, there, as Becca mentioned earlier, they have filters in them, and depending on the environment in your home, you may want to clean them more frequently. So one of the questions someone had asked regarding a wood stove, the wood stove will actually create a little bit of dust. And when you're running the heat pump, you'll probably want to clean those filters a little more frequently, as well as any pet dander and so on. You're going to want to clean them a little more frequently as well.
Thank you, Dan. Yeah, that's a great point. I think you answered it. If anyone else wants to weigh in, just wave at me, but I feel like that was spot on, Dan. Thanks. And we actually had a comment from an audience member who asked if they could see the Green Mountain Power contact information again. So Dan, if you wouldn't mind putting that in the chat, if you feel comfortable, or we can show the slide at the end. You just let me know.
I will put my contact information in the chat.
Thank you. Okay, so next up we got, can these systems work in zones? I have a 12-room motel and want to know if this can work for us. So I'll just take a step back and say, sounds like you're in a commercial situation. And some of our utilities talked about their residential programs. There's also commercial programs, and there's rebates through Efficiency Vermont on the residential side. And we have folks who can help you through the commercial side. But yes, you can certainly do, I would say for a motel, that's a technical question. If you have like individual rooms, I would suggest getting someone to actually come out and take a look and see what the right fit would be. Retrofits with heat pumps, depending on what your former or your current heating system is, it depends. I don't know if anyone has any examples, if they have any motels in their utility, or examples of kind of those smaller rooms, if there's multi-zone options. But yeah, anyone got an example or comment? Oh, Dan's unmuting.
You actually, there are a couple companies out there that actually make a multitude of different units that you can put multiple heads on, in which it would be a good idea to actually have an installer come out and take a look. If you're in Green Mountain Power service territory, we could actually have one of our folks that do this, have the same role as I do, actually come out and kind of look at this location and make a determination if it would make sense or not. And one of the things that was mentioned earlier is the tier 3 funding. There's potentially some opportunity out there if it was going to be whole scale and do all 12 rooms to actually provide a little bit more incentive.
Thank you, Dan. And that is a little bit of what I was trying to get with the commercial piece too, which is a lot of our programs are also designed to support commercial businesses at a different extent. And Bill, I see you came on camera. Did you want to jump in on this one?
No, but thanks for asking.
Okay.
Just trying to join the crowd.
There you go. So Brian, go ahead.
Yeah, just call attention to the the distinction between like a single zone system, which I think you had illustrated earlier on, and then the multi-zone systems, and just study the efficiency numbers associated with those systems. And the single zone systems are going to be a more efficient solution. Whether or not that's the right fit for your application is another question, but don't disregard those numbers.
Yeah. Good point.
I can chime in to say that for many of the utility incentives, they are applied to the outdoor condenser. So your incentive will be applied to the number of condensers you have. If you have a multi-zone heat pump, that's one outdoor condenser to multiple indoor heads. If you have maybe 12 single zone heat pumps, you're looking at 12 incentives. So those will stack up.
Yeah. Oh, good point. Yeah. So there's an option out there for you. Especially, I would love to stay at a motel with a lovely heat pump. That would be a good treat. So then we've actually got a couple questions on a similar theme, and I think we talked about it during the presentation, but folks want to know, and I get it, we're all Vermonters, those cold winter days. what's the deal with that? So I'll just kind of combine a few questions here. So how well do these work at -10 or below? And then another similar question, hey, I've been told that my heat pump could work till 0 degrees, and now I'm hearing -17 degrees. So what are the savings there and the benefit once you get to those negative temperatures? And who wants to jump on that one? Who's got the coldest utility?
I'll take a swing at this.
Go ahead, Bill. Thanks.
The issue, the physics of extracting energy from a condenser outside drop as the outside temp drops, and as the difference between inside and outside increases. Each heat pump system will have its own particular efficacy or efficiency ratio. You can look this up. But I think the message is, and when Becca teed this up earlier, she showed a 1 kilowatt-hour input for a 3 kilowatt-hour transfer of heat. You're not making energy, you're extracting it, harvesting it, and delivering it where you need it. That number of 1 to 3 is going to drop. As it gets lower, it approaches 1 to 1. That's electric resistance heat. So the issue is, where do you stop using, if you will, if you have choices, using a heat pump versus maybe an existing fossil system? I'm not here to promote this today, but I can say coming soon and supplemented with Efficiency Vermont incentives, there's going to be a way to manage an existing fossil system with a newly installed heat pump, so that you have one intelligent brain thermostat operating between the two to make that decision automatic. So you can marry a fossil system with a heat pump system. The advice here is, don't use it when it's wicked cold out, because you're going to be spending essentially the same amount of money as you would for electric spacing.
Whew, there we go. And I realize we're ticking down the time, and we have a few more questions. So if you have to go right at 1, I'm going to stick around just for 5 minutes longer past 1 to answer a few more questions. But if we don't get to you, please, we have your email if you registered over email. So go ahead, and we are planning on picking someone from the prizes from that email list. So if you have a question that you want to get followed up on, feel free to email myself, Becca White, at Efficiency Vermont, bwhite@veic.org. You can go on the Button Up Vermont site and find information for each one of our partners, including all of our utilities here today. And I wanted to put one other piece here, because we got a ton of technical questions. You guys want to know the nitty gritty, and I can respect that. So if you are really looking at like my square footage and what type of heat pump and will it work in my brick or wood home, go ahead and ask for a virtual home energy visit. They're free through Efficiency Vermont. And we have some information about those at the Button Up website. You can get a virtual home energy visit. And one of those great topics to get some of those technical questions answered specifically to your home would be through that virtual home energy visit. And also all of our utilities here, every single one has offered to be a contact point if you have questions. So I know that they're ready and willing to answer those as well. So you'll see in the chat, we got that buttonupvermont.org/visit. You can check that out. So let's try to get maybe 2 more questions in as we wrap up. Oh, and Dan, I don't know if you're able to put your for some reason, folks are not able to see your contact information. So I'm going to add it to the chat, folks. So there we go. Okay, so we had another question around heat pump hot water systems, and I wanted to make sure we answered that. So what about on-demand hot water systems? Comparing that potentially to heat pump hot water systems, or are there on-demand heat pump hot water systems? Anyone want to take that one?
I'll take it. Yes. If it's fossil, I don't worry about it. If it's electric, I worry about it, because there's no storage, you're extracting or inducing a whole lot of electric energy to instantaneously heat it up from groundwater temperature to your operating temperature. It takes a lot of energy, it's typically in your service entrance, in your circuit breaker box, it's going to be a huge amount of load, like 40 or 50 amps. I've seen them as high as 120 amps. And if you have a 200 amp service, you're devoting, in that case, more than half your ability to carry loads in one thing. So be careful. I've had members who unknowingly installed it and blew the fuse on their transformer because everything was undersized compared to what that thing can do. So it depends what size you pick, depends how many gallons per minute the unit can handle. Smaller ones, not so big a deal. Bigger ones can be kind of a bad choice, in my opinion.
Good clarification. Anyone else have thoughts on this one? Oh, Brian, you unmuted.
Yeah, I'm not familiar with any sort of instantaneous heat pump technology. So it's all sort of just kind of chugging away in the background. So I don't know. I mean, that may be something to research.
Yeah.
This would be like, so I guess the point is it would be electric resistance on demand, which is what we're trying to move away from.
Right.
Totally. And it's interesting because, I think what I hear often with on demand is the benefit of kind of the quickness when you've got, you're trying to do something. Or if you've got a lot of folks in your home at one time, maybe using the hot water for multiple purposes. I haven't had, we've with our heat pump hot water system, we've definitely had the benefit of getting the hot water when we need it, even when we're running multiple things. So if that's a concern as well, when you're thinking about heat pumps, like, is this going to be quality compared to what I'm used to? I would say in my experience, anecdotally, yes, they do work effectively, and they definitely, I can do my dishwasher, my laundry, and somebody can be taking a shower, which is a nice thing. Okay, so we were able to squeeze in one more question there, but I see we've got a bunch more. So I'm going to wrap us up for today. But if you have questions, what I'm going to do is, if you've put them in the chat or in the Q&A, I'm going to go through at the end and see if I can snag folks and we can help get you some answers. But in the meantime, you've been introduced to our fabulous co-hosts. So if you see your utility on here, you've got their name, reach out, because they're the right folks to talk to when it comes to heat pumps, in addition to the folks over here at Efficiency Vermont. So thank you for sticking around for an extra 5 minutes. Thank you to all of our co-hosts for joining us as we talked about the combo of weatherization and heat pumps. A little bit of vanilla ice cream and maple syrup is what I like to think about with the combo of those two. So if you like that, please think about the combo for your home or for your business. So that's all for us today. Thank you, everybody, for joining.
Becca,
Thank you.
thank you.
Thanks, everyone.
Thank you. Bye.